Hello students, welcome back, and I believe today we're on notes number 3. And today we're going to focus on a couple of specific types of word problems. You'll notice I like to give you a lot of word problems because they give you the opportunity to apply what you're learning to different situations. So today we're going to be doing problems that are called work problems or work, rate, and time problems, as well as problems that are called distance problems, distance, rate, and time. Okay, I'm going to introduce you to a strategy that I like to use for work problems. And so here's the idea. The rate at which you're working multiplied by the time you work equals the total work done. So we're assuming that you're working at a constant rate. So rate times time equals work done. And so, for example, let's say that you can rake 1 yard in 30 minutes. So your rate is 1 over 30, 1 yard per 30 minutes. Let's say you work for 60 minutes, so your time is 60. So you multiply your rate by your time, and that would give you 2, and that's the amount of work done. And so in this case, that would be 2 yards raked. And another concept that we're going to need to do the problems today is that A's work plus B's work equals the total work done. So that's pretty intuitive. If 2 people are working, you add together their work to get the total. Okay, we're going to work through 4 different examples, 2 problems that are work problems and 2 problems that are distance problems. So here's our first work problem. Let's read it. It takes you 30 minutes to rake the leaves in your yard, and it takes your brother 45 minutes. How long does it take the 2 of you to rake the leaves when working together? Okay, so we have you and we have your brother. So let's say that your work plus your brother's work is going to equal the total work done. And to figure out your work, we need to take your rate times your time. And to figure out your brother's work, we need to take your brother's rate times his time. And that's going to give us the total work done. Okay, so what's your rate? Well, you can rake the yard in 30 minutes. So your rate is 1 yard per 30 minutes. What's your time? How long are you and your brother going to be raking together? We don't actually know. That's the question. How long does it take? So let's use a variable for that, and I'm just going to use t for time. Next, what's your brother's rate? It would take your brother 45 minutes working alone, so he can do 1 yard in 45 minutes, so his rate is 1 over 45. And what's his time? Well, the 2 of you are working together the whole time, so his time is also t. And what's the total work done? Well, you're raking 1 yard together, so it's just 1. Okay, so now we have this equation, and we're going to solve the equation. And because the equation has fractions in it, if you're like me, you like to clear the fractions. So let's multiply both sides of the equation by the least common multiple of 30 and 45, and that would be 90. So we're going to multiply both sides of the equation by 90 to clear the fractions. So the first term, 1/30th t times 90 would be 3t. And then the second term, 1/45th times t times 90 would be 2t. And then on the other side of the equation, 1 times 90 is 90. Okay, let's add the like terms. We get 5t equals 90. And then divide both sides by 5, and we get t equals 18. So what are the units here? It looks like it was minutes. So what is that telling us? It's telling us it would take you and your brother 18 minutes if you were working together to rake the whole yard. Now let's think about if this makes sense. So this is kind of a reasonableness check. Suppose that you and your brother were both raking at your rate. If you were both raking 1 yard in 30 minutes, how long would it take you together? Well, it would take you 15 minutes altogether. because you would do half, he would do half, 15 minutes to do half a yard if it takes you 30 minutes to do the whole yard. Now, what if you were both working at your brother's rate? So what if both rates were 1/45? Then you would do half, he would do half, and it would take you 22.5 minutes working together. So do you see how the answer we got falls in between those? 18 minutes falls in between 15 and 22.5. So that tells me that it is reasonable. It doesn't check it precisely, but it does check it sort of in a common sense kind of way. Okay, let's move on to the next problem. Number 2. A pipe can fill a tank in 10 hours while an outlet pipe can empty it in 2 hours. How long will it take to empty a full tank if both pipes operate at the same time? All right, so notice that this problem is a little bit different, and what we need to do is concentrate first on what's happening, what's the goal of the problem. The goal is to empty the tank. And so the amount of work done, the total work, is going to be emptying one tank. Now, notice that one of the pipes fills the tank and the other pipe empties the tank. So I'm going to call the first pipe, the one that fills, that's going to be pipe 1, and the other one that empties is going to be pipe 2. So let's start with pipe 2's work. And then we have pipe 1's work. Are we actually going to add the work together? In this case, I would say we should subtract the work because the filling of the tank is working against the emptying of the tank. So then let's find an expression for pipe 2's work. So we need pipe 2's rate times its time. And then for pipe 1's work, of course, we also need pipe 1's rate times its time. So pipe 2's rate. It can empty the tank in 2 hours. So one tank in 2 hours, 1/2. How long is it going to work? Well, we don't know. That's the question. How long will it take? So just like in number 1, we're going to call that T. And then pipe 1. What is its rate? It can fill a tank in 10 hours. So one tank in 10 hours. And how long is it working? Again, that's T. So now we have our equation. So let's multiply both sides of the equation by 10, the least common multiple of 2 and 10. And that gives us 5t minus t equals 10. So 4t equals 10. So t is 10/4. We can reduce that to 5/2, and we can call that 2.5. So 2.5 hours. So it takes 2.5 hours to empty the tank. Now let's think about the reasonableness. How long would it take to empty the tank if it wasn't being filled at the same time? 2 hours to empty by itself. Just using pipe 2. But because the other pipe is working against us, it's going to add a little bit of time. But because the filling pipe is going more slowly, it only adds a little bit more time. Okay. What we're going to do now is stop this part of the video, and I'll record a second video for part 2, which will have examples 3 and 4.